We are on planet Earth, so it's obvious to say that we're spinning around the sun. Alright, everyone knows that. Now, what if I told you that we're also orbiting a black hole? But there's no need to be scared because we won't be devoured by it. This isn't just happening to Earth, it's happening with Jupiter, Mars, Saturn, the Sun, and all the stars we see at night in the sky. Our entire galaxy is rotating around a black hole. To understand why this happens, we need to take a closer look at the black hole and try to understand why it's so intriguing. Welcome to Curious Mind. Hello, my dear friends, how are you? Please hit that like button here on YouTube, share the video, and subscribe to the channel to support this wonderful project. But let's get into the video now. Folks, we're so wrapped up in our reality here on Earth that it's sometimes hard to imagine what's happening in the cosmos. We're still piecing together the puzzles of our planet's past and present. Imagine the rest of the universe. We're discovering things here on Earth, but there's still so much more to uncover out there. In fact, the universe is an ever-present enigma that constantly challenges our scientists. And that's great. Science isn't afraid to acknowledge what it doesn't know. When you pretend to have all the answers, you close a door, the door of investigation, research, and the insatiable desire to understand the unknown. One of the big mysteries that fuels this thirst for knowledge is black holes. They are often portrayed in movies, cartoons, and science fiction series as something dangerous, menacing. Everyone knows that if you ever venture into space, a good piece of advice would be to stay away from a black hole. Not that you'll be casually floating through space, but if you do, keep your distance. But what exactly are black holes? Are they like monsters roaming through space, devouring everything in their path? Are they magical objects painting the universe black? No, no, no. A black hole is nothing more than the ghost of a star. What makes black holes so special is their incredibly strong gravitational pull. Nothing can escape their grasp, not even light. To understand how this works, we need to explore one of the biggest deceptions in the history of science. The legend goes that one fine day in the 17th century, a physicist named Isaac Newton was resting in the shade of a tree when he saw an apple falling from it. He began pondering why it fell and, in doing so, formulated the law of universal gravitation. Okay, that story never happened. However, this apple, even though it may not have existed, will help us understand one of the most fundamental rules of the universe, the law of gravity. Whenever two objects are near each other, gravity causes them to be attracted to each other. This law has two crucial features: the greater the mass of one of the objects, the stronger the attraction between them. Likewise, the closer these objects are to each other, the more intensely they attract. In Newton's story, the objects were an apple and our planet. The Earth is attracting the apple, and the apple is also attracting the Earth with the same force. But how is it possible that an apple attracts the Earth in the same way the Earth attracts the apple? Something seems off, right? Well, Newton cracked that puzzle. He was one of the brightest minds ever to grace the Earth, and he also formulated another law that you're probably quite familiar with, the law of action and reaction. For every action, there's an equal and opposite reaction. That's why the apple and the Earth are attracted to each other with the same intensity. The apple is at a disadvantage in this tug-of-war because it's pulled toward our planet due to its smaller mass. The law of gravity applies to every object in the universe, from planets to atoms, and even to people. Yes, you also exert a gravitational force. You don't float off into space because you're attracted to the planet, just as the planet is attracted to you. The difference is that Earth's mass is much greater than yours. But now, let's put Newton's laws aside and head back to space to take a closer look at the black holes you've all been waiting for. Now that we understand how gravity works, it's a bit easier to grasp the concept of a black hole. It doesn't just sit there in the universe, thinking, I'm feeling quite lonely, I'll start sucking everyone into me. No, it's not about loneliness, it's quite the opposite. It's irresistible, and that's due to gravity. We've seen that an object's mass directly influences its gravitational pull. A black hole is a celestial body with an enormous mass concentrated in a very small area, making its gravitational attraction incredibly powerful. In fact, you can think of a black hole as a cosmic drain. Anything that comes near it gets pulled right into that drain. One of the fascinating things about science is that even though humans have never gotten close to a black hole, we can still detect their presence and understand what happens on the outside. Around a black hole, there's a region called the accretion disk filled with matter in the form of gas. It's like a massive gas cloud. As this material moves, it heats up and emits ultraviolet, infrared, or X-rays, other types of light that we can't see. It was thanks to X-rays that we first detected a black hole. When we look directly at a black hole with X-ray detecting equipment, we see beyond just light, we see temperature. For instance, a star might go unnoticed by these instruments because its surface isn't hot enough. It shines at around 100,000 degrees Celsius. However, the gas disk being drawn into a black hole is much hotter, emitting intense light at over 100 million degrees Celsius, making it detectable by X-rays. And that's how we know there's a black hole there. But let's get back to our cosmic drain. Within the accretion disk, there's another area called the ergosphere. Here, matter that's about to vanish into the black hole is constantly spinning in the same direction, just like water around a drain. The last exit from the black hole is the event horizon. This is the boundary between what we can observe and what we can't. Anything that crosses the event horizon can't escape gravity and is sucked into the black hole, never to be seen again. Some black holes exhibit bursts of X-rays, emitted by gas that seems to be escaping from them. But that's an illusion. Scientists believe these bursts come from the accretion disk material that managed to gather enough speed to escape gravity before getting too close to the black hole. But the great mystery surrounding black holes is what happens when something or someone falls inside. Sadly, even to this day, scientists haven't been able to explain what occurs. If light and matter can't escape a black hole, how could we possibly see what's happening? Nevertheless, there are several theories. Many of them are linked to how black holes form in the universe. When you, my young and dear friend, look up at the sky and see hundreds of stars shining, you're actually looking into the past. The stars are so far away that their light takes